Hello everyone. In the today lecture we'll see what do you mean by uniform continuity. We have seen that what do you mean by continuity when in real analysis we say that fx is continuous at a point x belongs to, let's say, x in the metric space. What we say that for given epsilon greater than 0 there exists a delta greater than 0 such that the distance between fx and I say that what the c fc is less than epsilon whenever the distance between x and c is less than delta. This distance is in y metric space and this distance in the x metric space. So for every point for a given epsilon there exists a delta greater than 0. Suppose that I move to another point, say C1, this is C1, let it be C1. Suppose I move to another point C2 in x. For the same epsilon greater than 0 there exists a delta 2 greater than 0 such that the distance between fx and fc2 will be less than epsilon whenever the distance between x and c2 is less than delta 2. Let it be this delta 1. So the delta 2 depends not only on epsilon as well as the point where we are taking in the x. Which one is taken in the x? Okay, so the problem is that whenever I change the point in x, the delta will change. If I get a uniform delta that will work for every point in x, that means if delta depends only on epsilon, then something new happen. Means for every epsilon, just there exists a delta depending only on epsilon, not on the point of x. Then we call that continuous function is a uniformly continuous function on x. Then we say fx is uniformly continuous on x. So from this we can see that continuity we say at a point but uniformly continuity on a set x. That's why always we say that the continuity is a local property and uniform continuity is a global property because it works on, we say, on x. Okay, so I am writing the definition, proper definition, what do you mean by uniform continuity. So here we have the definition. Let x comma dx and y comma dy be two metric space. A function f from x to y is said to be uniformly continuous on x. Okay, if for every epsilon there exists a delta that is depending only on epsilon such that, what's that this statement? I just saying that, then I will explain this one. So I first of all that for every epsilon there exists a delta which work for every epsilon and irrespective of the points. Now take easily elaborate kuru. Suppose I have a metric space x here, another space is y. Okay, so f is a function. I say that f is uniformly continuous. That meaning for a given epsilon, so epsilon is given to us. Okay, there exists a delta greater than 0 so that tome jensi bi jude point niyo x1 x2 duita x re jodi tankor mojire distance ta less than delta hai tankor image bhitre distance ta less than epsilon haba, tankor bhitre distance ta less than epsilon haba. So whenever the distance between x1 and x2 in x is less than delta, the distance between the image point is less than epsilon. So irrespective of the point in x, whenever you take 2 points in x1 x2 in x where the distance between them is less than delta, the image distance between them is less than epsilon, and we call is as uniformly continuous. So first of all, understand the definition and then we'll go for some examples. Okay, so next we know that everyone means as we say that continuity is a global property, whereas uniform continuity is a global property, whereas continuity is a local property. Whenever the function is continuous on uniform continuous on x, then it is automatically continuous on x. We can prove easily. Every function f from x to y which is uniformly continuous, on x is necessarily continuous on x. Continuous on x means if the function is uniformly continuous on x, it implies that it must be continuous on x, but the converse is not true. That means if a function is continuous on x, then it may not be uniformly continuous on x. So I am writing this definition also. The converse of above statement is not necessarily true. That means if a function f is continuous on x, then it may not be uniformly continuous on x. Okay, I will give an example. Let's consider a function f from real number with the usual metric to real number with the same usual matrix, that is modulus metric, defined by f of x equal to x square. We will prove that the function is continuous but not uniformly continuous on R. Okay, we have that fx is continuous on R. Fx equal to x squared is a polynomial function. This is also continuous on R, or I can say that it is a product of two continuous functions. Since I can also write it is a product of two continuous function, that is x and x. Okay, so I will show that it is not uniformly continuous. Now the very important point, what do you mean by not uniformly continuous? Not uniformly continuous or definition taka. Okay, what is a uniform continuous? For every epsilon there exists delta, means there exists a epsilon greater than 0. For every epsilon, draw negation, there exists an epsilon greater than 0 for which there exists a delta, but for all delta greater than 0. तार मीनिंग करा हुआ तो मैं एमता एप्सिलॉन टे दिया है पा तो मैं जेन भी डेल्टा नहीं हो. सो इफ distance between x1 x2 each less than delta, the distance between f of x1 and f of x2 is not less than epsilon, this is greater than equal to epsilon. So whatever you take the delta, we have 2 points, there exists 2 points x1 x2 in x, there exists x1 x2 in x as the distance between them is less than delta, implies the distance between f of x1 and f of x2 is greater than equal to epsilon. Again I am repeating, not uniformly continuous definition is that there exists an epsilon greater than 0. Whatever you take the delta, there exists 2 points x in x, x1 x2 in x, such that the distance between x1 x2 तो मैं जिन भी डेल्टा नहीं हो, we will have 2 point x1 x2 in x, such the distance between x1 x2 is less than delta, but तांकोर image with the distance ta less than epsilon नहीं हुए, means greater than equal to epsilon. So we will show that the function is not uniformly continuous, that f of x equal to x square is not uniformly continuous. We will prove this is a method of contradiction. Let us assume that f is uniformly continuous. Let's take epsilon is equal to 1. That means there exists a delta greater than 0. Okay. So I choose 2 points. Let x1 is nothing but delta by 2 plus 1 by delta, and x2 is equal to just 1 by delta. Why I have chosen these 2 points, I will explain this later. So I choose 2 point x1 x2 such that now I will show that the distance between x1 x2 is less than delta. But is x1 minus x2, that is delta by 2, which is strictly less than delta. So the distance between x1 and x2 is less than delta, and since we have assumed that the function is uniformly continuous, implies the image distance must be less than epsilon. The distance between the f of x1 and f of x2 is less than epsilon. What is the epsilon? We have this one. What is the f of x1? Now we will show that f of x1 minus f of x2 must be less than epsilon. If it is not less than epsilon, then our assumption is wrong. So what is f of x1? Delta by 2 plus 1 by delta whole square minus 1 by delta square. Del square by 4 plus 1 by del square, 2 into delta by 2 plus 1 by delta minus 1 by delta square. More. Cancel. Is nothing but 1 plus del square by 4, which is strictly greater than 1. That is nothing but our epsilon. So we have 2 points f of x1 x2 whose distance between them is less than delta, but the image distance is greater than 1, is epsilon greater than epsilon. Hence, which is a contradiction. So our assumption is wrong. So our assumption is wrong. Hence fx is not uniformly continuous. Okay, again we see some certain examples for uniformly continuity. So I have written an example. Let A and A be a subset of a metric space x comma d. Define a function fx is nothing but the distance between x and a. Now the very important thing, what do you mean by distance between a point and a set? Suppose I have a metric space this x and I have a subset a. Okay, so I take a point x belongs to x. Okay, what do you mean by distance between these x and the set a? The distance between x and a is defined as, so I take the any y belongs to y a and find the distance between x and y. Distance between x and y belongs to a. For every these I find the infimum, the smallest distance. So I find the distance between this, every point from this one. I find every distance of this x from every point in y. I take those is the distance between x and a, which is the minimum, infimum. So I mean distance between 2 point bahar karwa sikhitila abe tak, but what is the distance between a point and a set is defined is like here. Distance between x and a is the infimum of distance between x and y for every y belongs to a. So we have defined how to find the distance between a set and a point. Now I define a function fx is nothing but distance between x and a for x belongs to x. Okay, such that f is uniformly continuous on a. अच्छा जदि आमे suppose that good example कहू छै जागा रे, well if x टा जदि a रे रहबा, what is the distance between x and a? Then I can easily say that the distance between x and a is surely 0, because jodi x ta bhitre rahla, the distance between x and a is obviously 0, because y jagare x ta aswa hi aswa, distance between x and x is 0, so infimum is 0. So if x ta a re jodi haba, distance between x and a is 0. So more function am ta define hoyeche fx is equal to distance between x and a for every x belongs to x. So I need to show that that function is uniformly continuous on x. Okay, we'll show that. Okay, for uniformly continuity we'll take, let more aim hoche need to show that distance between f of x1 and f of x2 is less than epsilon whenever the distance between x and x1 x2 is less than delta. Let consider 2 point x1 x2 belongs to x and a y is in y is in a. So I take any 2 point in x and y, an element in a. The distance between x1 y is less than equal to distance between x1 x2 plus distance between x2 and y by triangle inequality. Now we can say that distance between x1 comma y minus distance between x2 comma y is less than equal to distance between x1 and x2. That is equation 1. Similarly, I can say that distance between x2 and y is less than equal to distance between x2 comma x1 plus distance between x1 comma y, implies distance between x2 comma y minus distance between x1 comma y is less than equal to distance between x1 x2 likhe parma because of the symmetricity. That is equation 2. From 1 and 2 I can say that देखो distance ida e jinista ta negative hai. Okay, from 1 and 2 I can say that this one is the negative of this one or this one is the negative of this one. So I can say that modulus of x1 y1 minus distance between x2 and y is less than equal to distance between x1 and x2. Now I am taking infimum over y belongs to a. I am taking infimum on both sides over y belongs to a, means for every y. So what this is true for every y because y I have taken chosen arbitrarily. So what will happen, that implies this is nothing but what happened, distance between x1 and a because infimum minus distance between x2 and a is less than equal to distance between x1 and x2. Now what is my distance between x1 and a? So what is that fx here? Distance between x and a. So this is nothing but f of x1 minus f of x2 is less than between distance between x1 and x2. Now the distance between f of x1 and f of x2 is less than equal to distance between x1 and x2. Now the important thing, now what's my aim? Let epsilon greater than 0 be given. My aim is to show that f of x1 minus f of x2 is less than epsilon holds if from the last line my aim is to show that the distance between f of x1 and f of x2 is less than epsilon. This less than epsilon holds if distance between x2 is less than epsilon. That means choosing delta equal to epsilon, we have distance between f of x1 f of x2 is less than epsilon whenever distance between x1 x2 is less than delta. That means f is uniformly continuous on x. That is, f is uniformly continuous on x. Achha, just I have done a single mistake. In place of modulus, I have to write distance between f of x1 and f of x2. That is nothing but distance between f of x1, f of x2. Because modulus is in real number, so this also replaced by, I will replace by distance between f of x1 and f of x2. Okay. So in place of modulus, I just write distance between f of x1 and f of x2 in y. Okay. So I am just giving another definition. So there is another result. Let x comma d be a metric space. Let x belongs to x and a be a subset of x. Be non-empty. Then x belongs to a closure if and only if the distance between x and a is 0. Or I can say that distance between x comma a is 0 if and only if x belongs to a closure. So as I told earlier that what is my distance between x and a? The distance between x and a is defined as nothing but the infimum between distance between x and y for every y belongs to the set a. So we have already seen that if x is in a, then distance between x and a is 0. Now what do you mean by distance between x and a is 0 also if x belongs to a closure? What do you mean by a closure is nothing but a union a x. That means if x is a limit point of a, if x is a limit point of a, then distance between x a is also 0. As I told that what do you mean by limit point? Limit point is very if x is a limit point of a not in a, x is a limit point of a not in a, then means x is very close to x, very close to a, because x is a limit point of a. So x ta jodi limit point of a hoche, that is very close to x. Jete close ame ki jete san bhabu so tanu bhi close hoche bhitre, means there is no gap between x and a. Okay, we will prove this one. The important result which will be used in Eurasian's lemma. The next lemma we will use this one. Let's suppose that assume necessary part. Let distance between x comma a is 0. My aim is to show that what is my claim? I will show that x belongs to a closure. Okay, for any x belongs to x, either x is in a or x is not in a. Either x is in a or x is not in a. If x is in a, then automatically then x belongs to what happened? A closure. The x ta a also automatic x ta a closure hoga, because a closure is nothing but a union 8x. So let x is not in a, but what they given the distance between x and a is 0. Now that means we will show that x is a limit point of a. That means x belongs to 8x. Let us assume that, so I need to show that x is in 8x. X is the limit point of a. Acha, given that what is the distance between x comma a is 0 is nothing but the infimum of distance between x and y. Y belongs to a. By infimum property, what is by infimum property? This I am just saying what is the infimum property. हमको ये जिनिस का एग्जांपल लिखवाना है ना कि खातारे मींस हम प्रूफ लेना. If m is the infimum of a set A, then m plus epsilon is not a least upper bound, or sorry, is not a lower bound, because m is the greatest lower bound, then m plus epsilon is not a lower bound. Then in this gap m and m plus epsilon, we must have an element of the set S. That's the infimum property. From that one down, the infimum is 0, the m is 0, this is 0 plus epsilon. So from the infimum property, what we have, for a given epsilon greater than 0, this is 0 and this is 0 plus epsilon. For a given epsilon greater than 0, in this gap we must have an element, of the set. There exists y belongs to A such that distance between x and y is less than epsilon. So this is the infimum. What is the 0? Is the infimum of the d of xy. D of x comma a is 0 now. So we must have an element of the set A, y belongs to A, such that distance between x and y is less than epsilon. So by infimum property, we must have an element in the set A such that distance between x and y is less than epsilon. This y is not in 0 epsilon. Means what is the set? This set na distance between x a. तो ई सेट रो गुटे एलिमेंट बारवा ई सेट रे कण আছে d of xy আছে. So we have an element y belongs to A, so that the element is d of xy, which lies in 0 to 0 plus epsilon. So distance between x and y is less than epsilon, means y belongs to the open ball of center x and radius epsilon. Okay, that means every open ball of x center at x contains a point y belongs to A other than x, implies x is a limit point of A, implies x belongs to A closure. So in the both case we have shown that x belongs to A closure. Now sufficient part or converse part. Let x belongs to A closure. Need to show that, what's my claim? Distance between x comma A each equal to 0. Now x belongs to A closure, that is nothing but A union A at x, implies x is in A or x is in A at x. If x is in A, then automatically distance between x and A is obviously 0. Now I will show that if x is in A at x, then distance between x comma A is 0. X belongs to A at x, that means for every epsilon greater than 0, there exists a y belongs to A such that distance between xy is less than epsilon. What do you mean by this? X is a limit point of A, means every neighborhood of x contain element y of A. So distance between xy is automatically less than epsilon. For every epsilon, whatever you take the neighborhood of x, there exists an element, because y is the limit point of A. There exists an element of A in this ball. That means distance between x and y is less than epsilon. Hence, what we have, distance between xy is less than epsilon. This is true for every epsilon greater than 0. So taking infimum on both sides, infimum over distance between xy, y belongs to A, is automatically 0, because there is a result in the real analysis. If this is true for every epsilon, then A is equal to 0. So infimum of distance between x and y is 0. So distance between x comma A is equal to 0. So we have shown that distance between x comma A is 0 if and only if x belongs to A closure. Thank you. In the next class we will see what is the duration lemma.